During disassembly, all parts have been washed and inspected for possible damages. Damaged parts are replaced. Installation of hubcase bearing frames in a bearing and axle gasket. The disassembled, carefully washed hubcase is placed in hydraulic workshop press. Using a workshop press and suitable pressing bits, the outer frames of the bearings are installed into the hubcase bearing housings starting from the frame of the outer bearing. Make sure that the bearing frames are pressed all the way to the bottom and are firmly gripped. If the outer frame is loose when installed, the hubcase must be replaced. The hubcase inner roller bearing is lubricated and installed on the outer frame of the bearing. Fretax installation gel 595760000110 is applied to the outer surface of the gasket. The gel prevents the rubber surface of the gasket from binding to the edge of the hub during installation. The gasket is installed in a workshop press using installation tool 753407120. The spacer ring pressing against the axle gasket is installed on the axle tube in case the ring needs to be replaced. The spacer ring is of clamp type, and for installation it is heated to 120 Celsius degrees using, for example, an induction heater or an electric hot plate. A locking glue, for example Waken Lock AN30638, is used in the installation. The glue is spread ribbon-like on the surface of the spacer ring in the axle tube. The hot spacer ring is quickly pressed in place against the shoulder of the axle tube, using a tool or suitable protective gloves. Once the glue cools down, it locks and seals the shrinking spacer ring in place. Prior to hubcase installation, the inner frame of the outer roller bearing to be installed in the internal gear body is installed. The outer frame is installed in the hubcase. The bearing is heated to 120 Celsius degrees using an induction heater or electric hot plate, for example. The bearing is placed on the hub of the internal gear and hammered into place using an installation tool. Hubcase installation. An installation stand and lifter are recommended for the installation of the hubcase, allowing the hubcase to be installed upright without damaging the gasket. Prior to installation, the axle gasket is lubricated with Fretax installation gel to prevent the gasket surface from seizing. Lubricants evaporating more quickly, such as cleansing sprays, may be used, but in this case the installation procedure must be rapid. The hubcase is pressed in place as straight as possible, ensuring the integrity of the axle gasket. Once the hub is installed, the spacer ring is installed on the axle tube, together with adjustment plates collected during the disassembly. The thickness of the adjustment plates may need to be altered when adjusting bearing clearance. Internal gear and internal gear body installation. After the installation of the spacer and adjustment plates, the internal gear and body are installed by pressing it onto the axle tube inside the hub case. The thread of the nut is lubricated with oil and the locking ring and nut are installed. The nut is tightened to a 1000 Nm torque while spinning the hub. If a suitable torque range is not available, the nut is tightened using an angle system. The nut is first tightened to touch the surface so as to remove any hub clearance. After this, the nut is tightened using a wrench the distance of the angle between two wheel bolts, about 72 degrees. Once the hub nut is tightened, the hub bearing clearance is checked and adjusted if necessary as follows. A suitable non-elastic string is wound around the wheel hub. A spring scale is attached to the string. The spring scale is used to pull the string, at the same time checking the amount of the traction force required to rotate the hub. This must be in the region between 43 and 71 newtons, giving the hub a rolling resistance of 8 ± 2 Nm. If the traction force is larger or smaller, the nut and the locking ring are opened, the internal gear and body are removed and the thickness of the adjustment plates is increased or decreased as necessary. Once the nut is tightened and the bearing clearance is correct, the locking screws are installed in the nut. The smaller locking screw is installed in the nut hole aligned with the hole in the locking ring. Note: if the locking ring is of the old model with round holes, the nut may need to be tightened to align one of the holes in the nut with the hole in the locking ring. The new model locking ring has longitudinal holes, allowing one of the nut locking screw holes to always align correctly. A locking glue, for example, Vacon Lock AN302, 43 or equivalent, is applied to the threads of both screws. The nut locking screws are tightened to a 12 Nm torque. Installation of drive shaft, planetary gear and hub cover. Once the hub bearing clearance is adjusted and the nut is locked, the drive shaft is pushed into place. The sun gear is installed at the end of the drive shaft and locked with a locking ring. After this, the assembled planetary gear is installed in place. While the planetary gear is pressed and hammered into place using an alignment drill, care must be taken to ensure that one of the 5 incisions on the outer edge of the planetary support is aligned with the hub cover mounting screw hole. The planetary gear is locked in place using a lock ring in the hub case installation groove. A new O-ring is installed in the hub case cover sealing slot and lubricated with oil. When the hubcase cover is installed in place, it must be ensured that the mounting screw hole on the cover oil drain plug is installed with the hubcase mounting hole next to the incision on the planetary support. This way the planetary support incision can be seen from the open oil drain hole. The hubcase cover mounting screws are installed and tightened to a 60 Nm torque. The hub is spun until the oil drain plug is at the bottom. The magnetic oil drain plug is tightened to a 50 to 70 Nm torque. The hub is filled with recommended oil to the lower edge of the oil filling/inspection hole. The oil filling hole plug is installed and tightened to a 50 to 70 Nm torque.